All right, welcome. Great. So this is Introduction to Machine Learning for Artists. Did you guys see that it was machine knitting in there? Did anyone get confused? I thought I was going to come in here and start teaching you guys how to knit. But today is Introduction of Machine Learning to Artists. My name is Nye. I am the new Associate Chair and currently the Acting Chair of ITGM. Machine learning is a real passion of mine. And I'd like to essentially get artists access to it. I think it's extraordinarily inaccessible. Up till now, you had to be a data scientist and you had to work for Uber or be at MIT or something like that. And I think that there's a revolution that's going to happen where artists are going to get access to machine learning. And so I want to promote the availability of artist accessible model training because I think it's going to augment our work in crazy, crazy ways. And so that's what this session is about. So I'm going to talk a little bit about my ML story, how I started with machine learning. Then I want to talk a couple of things about how it's going to become more accessible. And then I want to hit two flavors of machine learning today, CNNs and GANs. And then at the end, I'm going to show you how to get going and put it into your own work. Because I think the best way for you to learn is just to open up some models and start hacking. And I'll show you some of my tomfoolery at the end. Okay, sound good? Great. So I'm going to press start. And it looks like I've already been going for a few minutes, which is fine. Okay, so let's talk about my story first. So again, my name is Nye. Before I came to SCAD, I kind of bounced between being sort of a screw up and somebody who got paid by the movies. So I would go to the movies. This is my credit from Oblivion. I was working at the third floor. On this piece, I worked on the third floor. I worked at Digital Domain. I've done some contracting for Disney. I'm heavily into computer graphics. But then I would also, as a movie would end, I would take a few months and I would draw cartoons, or I would make a video game, or I would, try machine learning. I'm very much sort of a basement hacker. And so I fluctuate between these two. So my story starts when I was on a mocap stage about 2.5 years ago, and I was talking to a company called Dynamics with an X, Y, and Z. I don't know if anyone's heard of them. They are a facial capture company. And I was talking to the guy, and he said to me, okay, well, you need to train the model for the face poses. And I said, what do you mean you need to train the model? And he said, oh, well, we have a proprietary model and blah, blah, blah. And I said, no, hold back. I want to know what the hell you're talking about. And that was my first sort of 2 to 2, where I put the two. I mean, I've heard of AI and I heard of machine learning and whatever like that. But it wasn't until that particular moment that it hit me like a ton of bricks, where I was like, wait a minute. Machine learning is being integrated into the computer graphics pipeline. And we don't even know about it. It's already here. It's already amongst us. And so at that particular point, I went way down the rabbit hole. And the first thing I did is I got on Google and I typed in machine learning. And I wound up founding a Coursera class by Andrew Ng. And I watched it and I had no clue what he was talking about. Absolutely nothing. Zero idea what he was talking about whatsoever. And I got really frustrated. And I was like, you know what, I'm not going to give up so easily. And so I began to bang my head against this. And for many, many months, I was trying to read things. I was trying to understand things. And most of the time when you say, hey, how do I learn machine learning? Everyone goes, you should learn how to code. And you should learn linear algebra. And you need to learn data science. And you need to learn all these things. And it was not practical for me to get a PhD in data science. It just was not practical for me to continue to draw cartoons and learn data science. So I had to learn how to be an artist and use machine learning. And that's what I want to teach, which is how do you use machine learning if you're an artist and you're not a data scientist? The example that I would like to call your attention to is the graph editor. So if you go back to computer graphics and animation and around the age of Tron, there was no graph editor, right? So if you were trying to move the light cycles around in Tron, does anyone know Tron? Am I that old? So if you want to rotate a light cycle or whatever, they would have to hand key these things. And by the time Pixar and Tin Toy and that kind of stuff started coming around, there was this invention of how do we manipulate X, Y, and Z data using a graphical user interface. And this is how animators were actually able to start doing very complex computer science tasks by creating an interface. And I believe that this same thing is happening right now with machine learning. Right? It is inaccessible for the most part because it is Python-based, shells or, C++ or whatever it is. It's code-based stuff. But graphical user interfaces are going to come flooding into your Photoshops and your Mayas and your Unities, and you are going to start playing with these machine learning tools. It's going to become accessible very, very, very quickly. This is what I mean by accessibility, is that you have this amazing force in the cloud that already exists. If you think about the amount of data and the amount that is being spent, whether you're in, the Chinese are spending hundreds of billions of dollars. There is all kind in venture capital. It's amazing how much money is going into this thing. And if you look at the developments with Uber and Facebook and even augmented reality at companies like Apple or what NVIDIA is doing, all of these companies are rapidly moving forward with neural networks. The problem is accessibility. The problem is coding based, and you are going to see this accessibility cross over in the next 5 years or so. So if you're in college right now and you get a jump on this, you are going to become extraordinarily valuable because you are going to know how to use it, not just I'm going to integrate it, because people don't even know, okay? I've only been doing it for 2 years, but you know what? I'm still ahead of a lot of people. A lot of people haven't even heard of it, and people don't even understand it. And so that's why I'm trying to help today. I'd like to talk about 2 flavors of machine learning because machine learning is sort of this thing. You know what? I'm gonna improvise here. If you think about this, and I don't know if you guys can see this, if this is all the entire field of what's called artificial intelligence, okay? This is a field that was started in the 1950s, of computer science. Everyone might have heard of the Alan Turing and the Turing test. This has been developed for a long time. It's basically the study of how do you make a computer think. And a lot of this has been very slow in the last 50 years, but it has rapidly accelerated because of these 2 guys, I think, the CNNs and the GANs. And artificial, if you sort of map the entire field of artificial intelligence, it's an extremely huge field of computer science. And then within it, you have machine learning. And then within that, you have deep learning, okay? And this is sort of a function of data, okay? So most of AI, I like to say, is sort of an if-then thing, right? When you go into Unreal and you set up an AI and a behavioral tree, it is if this happens, then that happens, okay? It's not really much more complicated than that. Machine learning is the first time that you're actually creating a mathematical model and you're having it learn. Especially CNNs, which we're going to start with. And CNNs are about learning patterns. And then we're going to talk about GANs, which are about taking all that data and then finding the patterns in it, but then outputting an image for it. Okay? So these are two parts of the pipeline, and they're really very, very interesting. So let's talk about convolutional neural networks for a second then. So convolutional neural networks are this way that you can identify patterns. So you notice that we have this pixelated orc on the left-hand side, and you'll notice that his shoulder has a tiny little square. And if you zoom in on a pixel-by-pixel basis, you might get something that looks a little bit like this, which is the box sort of in the middle there. Okay? You could think of a computer being able to image the entire thing and look for this 3x3 box grid. So very simple, right? If we created a loop statement, we could search through the entire image. And from that, you might be able to derive, at this particular moment, a pattern. We could then set up what is a model, which is called a perceptron, which is a little tiny way that the computer can, or the software can like see, quote unquote see, right? And essentially what it is it mathematically compares the two. And it says, if this looks like this, go off, turn off, fire, like a neuron in a brain. And you'll see there's a little like sort of, measure stick. So as it gets around, as it recognizes those particular patterns, these things will fire. And these are what the neurons in a neural network do, okay? So to start with, you could be recognizing edges, right? Or maybe corners or diagonals, right? As you analyze these things with different ones of these perceptrons, you can quote unquote see different patterns. So you might have seen this before. That's what this is. This is a whole series of these little perceptrons tied together, and they're scanning an image to be able to develop what it will look like. And the result is that you can quote unquote see patterns. You can see the outline of something. You can see the color of something. You can see the style of something. So ConvaNets have been in development for the last, I say decade is when the real movement was. And I think the real traction started to happen, I think, in the early 2010s, in the early teens, when they started connecting databases to it. So if you do a search online, you might see something called ImageNet. So ImageNet is a database of images that have been tagged. So there are ducks and dogs and cats and whatever. And connecting ConvaNets to this ImageNet, you're essentially able to train a ConvaNet to be able to recognize imagery. So this is ConvaNet. So if you walk through China, there's ConvaNets everywhere. They're tracking our faces all the time. Every time you open your phone, that you're doing a ConvaNet. Every single time that you're doing anything with Snapchat, with little eyes and ears, you're making motion, you're doing things, anything that you're recognizing a pattern and then you're training a model on that pattern, there's a variance to it, but for the most part, your get is a ConvaNet. Okay, so I'd like to demo a ConvaNet really quickly for you guys. So this is a model that I built. I used a software called Lobe.ai. This is completely free. It was bought by Microsoft. You can download this today. So instead of having to go through a year and a half of learning Python and learning data science and everything like this, within 5 minutes you can download this and put this on your computer. This is a really beautiful UX, really great, and I'm very excited about this software because of a number of reasons. So I've been training a model to recognize either robot or human. And as you see, what you can do is you can bring in all this data. So I've been importing images of humans and saying to the model, this is a human, this is a human, this is a human, this is a human, this is a human. I've also been doing the same thing with robots, right? So if you can find a bunch of robots down here, you'll see that I just found a whole bunch of robots. Now, how did I get these images is a whole nother ball of wax. I scraped the internet for them. I'm gonna push scraping and image manipulation out of this talk. I think that's a future talk, but let's just say that I was able to get a huge data set of robots and a huge data set of images of humans, and I put them together and I trained a model. So I trained this model to be able to recognize both of them. So let's go ahead and play with this model now. So now that I've trained this model, this thing will be able to recognize robots or humans. So I'm going to do an image search for let's say robots, and I'm gonna do images, and okay, who would like to choose something? Let's hear it out there. Okay, let's say, right, this is the robotic dogs to map 3D Factory. These things are terrifying. I think this would be great for a platformer or something. Okay, so I'm gonna drag it in here, and it is very quickly identified that this is a robot. Yes, you are correct, model. Should we do one more? Let's try to do a human. Okay, so ooh, look at this one, man. Do you think this? I'm not even gonna go there. Let's Somerville Writer. Let's take this guy, whoever this is. I'll drag that in. It is human. Yes, model, you are absolutely correct. Okay. So once I have trained this model, you notice that there's a training right here. it is going to continue to train, and I can then go ahead and export. And you'll notice that it says TensorFlow, used for cross-platform applications. Wow, that would be amazing. So instead of me having to learn TensorFlow and get in that kind of stuff, I can use an off-the-shelf software, and I can train a model, and I can export the TensorFlow model, and I can import that in. So if I had a driving game or a dancing game, I could train an AI to recognize my motions or my facials or when I'm drinking coffee or any of these kinds of things, and I can plug this into software without any code whatsoever. So start thinking in terms of ConvaNets as what are things that I can train? What models can I train to be able to do this amazing stuff? So that's ConvaNets. This one blows my mind. This one is called Generative Adversarial Network. They're very often called GANs, okay? So these were invented primarily by this guy. I mean, the field itself is compounded, I know, standing on the shoulders of giants and all that kind of stuff. But generally, Ian Longfellow is regarded the guy who came up with this. And he was a graduate student about a decade ago. Again, it's not a very old field. And he was working with generative models. Now, these generative models are procedural models that are able to create imagery. So he went out to a bar one night and was drinking with his buddies, and they said, you know what would be hilarious if we took two models and we had them fight against each other. So he went home, probably half drunk, and he actually did it, and he created the first GAN, which is a generative adversarial network. And what it is there's a generator which creates a series of images, and then there's a discriminator that looks at the images and goes, that's fake. And so the generator has to get better because it's trying to fake out the discriminator, and the discriminator is trying to get better to fake out, to stop the generator from creating. And as they both learn, they both fight against each other, and they become extraordinarily, extraordinarily amazing. So just as a point of reference, which one of these is fake? Anyone want to make a guess? They are both fake. Yes, this was created by a GAN. This is actually a model that's 2 years old. StyleGAN 2 by NVIDIA has actually gotten better than this, believe it or not. And this is built off of an enormous facial data set that of thousands and thousands of images that are being scraped. So, next time you're tagging yourself on Facebook, you might be thinking, you know what, I'm training a GAN right now. So both of these components, you've got the convolutional neural networks and you've got the generative adversarial networks, are sort of the key components in a larger machine learning pipeline. I would like to talk a little bit about a GAN and how I started to think about GANs. Okay, so when I was taking a class in machine learning and one of my projects was to build a GAN. And I used StyleGAN 2, and I decided to do this with Captain Kirk. So what I started with was I went to the original Star Trek, the TV show, and you notice that it's edited. You see how I actually have sequential images of Captain Kirk. So it's only 1,800 images, right? Wasn't very good, and as I trained it for 1,500 steps, which means that the entire GAN went through 1,500 times, went through processing, these are the images that it produced. Now, it kind of got, his skin coloring and then the shirt a little bit and some stuff in the background, but the model hadn't really crystallized. It hadn't really quite understood what it was. And I realized that I had done a number of things wrong. I had given it bad data, okay? So I went back and I needed a lot more data, and I found, it was incredible, I love YouTube. I found this guy on YouTube who had edited 80 worth of Captain Kirk shots, 80 minutes worth. And so I went through, I wasn't quite as good at image manipulation in Python by that point, so I was using After Effects at that point, and I took all these images and I lined them up in After Effects to make sure that they were all sort of roughly in the same area. I outputted thousands and thousands. I think there was like 16,000 frames. Yes, 16,000 images of Captain Kirk that were all sort of roughly in the same era. So I built another model on top of the other one, and I fed in the first batch of these images. So this is 4,900 images. You'll notice that this data set here is a little bit more structured in order for me to be able to do this. And on the right-hand side, I was able to train it for 3,000 steps. Now this is the last training section. You'll see that there's 11,100 images. So I was feeding every 10th frame. So instead of it getting sequential series of frames, I was taking sort of rapid fire snapshots of what Captain Kirk looks like. And you'll see already, after it's training 5,000 steps, it's looking a lot more like Captain Kirk. Now it's still a little fuzzy in a lot of ways. And at the end, I'll show you what the output is. So by the end, I was able to feed 16,000 images of Captain Kirk on the left-hand side, which is the data. I fed it into NVIDIA's StyleGAN 2. This is called a latent spacewalk. We don't really have time today to talk about latent space, which is a damn shame because it's such a cool concept. But this is a latent spacewalk that was built on 5,000 steps. And then the generated images. So the thing about GANs is that they're 512 dimensional vectors. So if you take a series of 512 numbers and you just pump it into the GAN, you'll be able to create a random image of Captain Kirk, right? This is extraordinarily powerful, right? And I believe that the near future of our rendering is going to be data-driven rendering. So instead of us putting a series of images together and then, computationally creating a render, we're going to create massive GANs, which are essentially large sponges of data, which will learn, quote unquote, learn what something looks like. And then we will fire these vectors into these outputs, and it will create these realistic images. So between these two things, I've started to screw around with a bunch of stuff. So one of the things that I've been really interested in is a model called First Order Motion. And I can't really get deep into the pipeline today because we don't really have a lot of time. But effectively, what I was doing, it's sort of a cheap, it's kind of like the cheap fake. So this is the model here that I found from GitHub. It's kind of hard to see exactly, but this is the Vox Celeb data set. So basically, it's a whole bunch of faces that were created that a whole bunch of faces will come to and will train. So the model recognized kind of faces. So it said, this is a face, 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 this is a face. They have multiple data sets. They have a fashion data set, they have a horse running data set. So in my process, I created a sort of a rig that I could perform into the camera. I could feed targets into it, and then I would run this into this FOAMIA, First Order Motion of Image Animation model, which has this ability to swap out data sets. Using sort of GAN technology, I can do a local rendered output, and then I can do a final composite on the other side, right? This is all sort of my structural pipeline component, and this was my first test right here.
Greetings, fellow hobbits and humans. I am Gandalf the Grey.
Okay, so, I mean, kind of wonky, but, it's not like your traditional animation pipeline where you're doing different frames. You're essentially manipulating data in order to do animation. So it's kind of a different. This is another one that I did recently. I was playing with a library called Wave to Lip. This one is super cool. Basically, all you need is a wave, and it takes the wave and then it analyzes it to a lip data set, and then it pumps it in onto video. So this was something I did on a Sunday afternoon here, just a Schwarzenegger thing.
Everybody always asks me what are my major influences, and I have to say it's children's TV shows.
So you can see that obviously there's some warping here, but for a low purpose model rendered on a local computer with, I could fire this up onto a super powerful cloud computer somewhere where I could charge for 75 cents an hour or something like that. And I could probably make a pretty compelling deep fake of Arnold Schwarzenegger talking about Umizoomi children's television. Okay? So, how are you guys going to get up and going on all of this is really what I want to, and then I want to show you guys a couple of things to kind of get up and going. The first one is your research. Right, the best way to be sort of abreast of what's going on in the machine learning field is a website called archive.org. Everybody publishes their models there, right? And I'm gonna show a bunch of models after we're finished up here. So archive.org is a great place for you to get going. So if you go to Twitter, you go to YouTube, you can follow me at Nye Warburton, and you go and look through my following list. You will see that I'm following a whole bunch of machine learning artists. And then 2 Minute Papers is amazing. I watch everything they do. I would subscribe to them on YouTube. All of these things, in fact, I'm going to show you some 2 Minute Papers in a little bit. There's a group of guys that are taking Pixar movies and humans and they're meshing them together using GANs to be able to render humans that look cartoony. And you might see some TikToks that are doing this kind of stuff. There's a model, a guy developed it called Oldify, or De-Oldify, I guess that's what it's called, where you can feed old footage, it blows up the footage, it makes it colorized. It didn't use it using traditional colorization techniques. It used it by matching color footage to black and white footage, and then you trained GANs for the final output. Sort of, again, another data-driven rendering. And then I love this guy named Lulu. He does a whole bunch of style experiments where he takes footage and he runs different kinds of patterns to be able to change the patterns and looks of it. All kind of like artistic and smooshy and weird right now, but they're all going to be super crazy. If you want to get going, you want to get your hands dirty on this, I showed you guys Lobe AI. I'm going to show you Runway ML in just a second. We're going to look at Artbreeder and Ebsynth as well. I think the explosion is coming. And also Deepface Lab. If you do a search on the internet, it's all over the place. It's on a Russian site, so I can't in good faith tell you that you should go download it. But those of you who have got your own sort of security in place outside of SCAD, I think you guys can go and you can start developing your own deepfakes. But also I would watch the big companies, Adobe, Unity. Also, there's a lot of open source movement in things like Blender and Godot, right? Those of you who I've taught know that I'm a fan of Godot. I'm a fan of it because it's open source. I can use a machine learning library in it. I don't need to pay Epic a damn thing when I'm doing that. The books that I found that were most useful is Artificial Intelligence by Melanie Mitchell. This is a book that actually has a very pervasive cover on the entire field of it, and she abstracts all the math out of it. So she actually talks about things like convenets and GANs, but also classifiers and all these other kinds of like really complex things, but she makes them very, very explainable. And then The Inevitable by Kevin Kelly, who was one of Wired's, I think he was a senior editor of Wired for many years. I think he's retired now, but he wrote a really interesting book that helps me will help you think about how distributed networks are going to come and how data is going to be handled in a new cloud-based economy. Online video, Machine Learning for Artists on NYU by Gene Kogan. That was one of the biggest turning points for me. I remember I told you about the Andrew Ng class before. I think Gene Kogan's class was actually really helpful for me. There is something called The Coding Train by Daniel Schiffman. He has a series called The Nature of Code. It's also a book. It goes along. The unfortunate thing is he uses JavaScript, and I can't handle promises. So as a result, I think you can kind of abstract the conceptual ideas out of it, but the actual execution of code, unless you're into JavaScript, then good luck with that. You're going to get to a certain point, if you're really serious about this, that you're going to want to understand the tenets of linear algebra. The guy that I think on the internet who's the best is Gil Strang. He's an MIT professor. All of his lectures are available. Certainly watch the first 3 or 4, and it will really help clarify the understanding of matrices and plotting vectors and trying to figure out, because if you're thinking about 512 dimensional space, your brain explodes. So you need just a little bit of algebra to kind of get yourself going. And the last recommendation I have is Al Swigert, Automate the Boring Stuff with Python. The reason why I push Al Swigert versus Khan Academy or something like that is that his approach is to teach Python as a practical use case language, right? I'm not going to be programming tuples and functions and things like that. I'm going to scrape the internet, right? I'm going to take this image that's 512 by whatever, and I need to size it to this, and I need to run it through this library. That's basically data handling and image manipulation and automation. And the automation sort of approach to Python is what really you need, because when you're handling thousands and thousands and thousands of images, you basically need to batch process that output. I'd also like to say, hey, you should follow me on Twitter. If you guys are doing something in machine learning, please let me know about it. You can also email me directly at nywarbert at scad.edu. And I'm also going to put a Google sign up in the chat. Basically, I want to find who is interested at SCAD in machine learning. If there's a subset of people who really want to be utilizing proceduralism and AI and all this kind of stuff for this, I would like to be devoting resources to it, because I am 100% convinced that within the next 5 years, you're going to have a number of incredible advances in this field. And if you, as artists, want to be innovators in this, I would really love SCAD to have a presence. And in fact, it's sort of a big tenet to why I am here. So if you would like to be part of that, please sign up. Let me know, communicate with it, and I'll probably pull you into a Discord, and hopefully we can get some chats. Okay? So I'm going to leave about 10 minutes for questions, and as I do this, I'm going to start showing you guys some stuff. I'm going to launch Runway and give you sort of a fast overview on Runway. We already did Lobe AI, and then I'm going to touch on a couple of other things as well.